Next topic, that is Wheatstone Bridge. Wheatstone Bridge, that is the circuit with the help of which one can find the unknown resistance. Okay. So first we have to understand theoretically the circuit of the Wheatstone Bridge, and then after we will discuss the experimental circuit which we use in laboratory. Now see, in Wheatstone Bridge circuit, a loop is formed by connecting four resistors as shown in this figure. A to B one resistor, B to C another resistor, C to D the third one, and D to A fourth one. So using four resistor here, a loop is formed. Then after, between two diagonally opposite points, here between B and D, a galvanometer is connected, and between two remaining diagonally opposite points, battery is connected. So this particular circuit prepared in this way, that is known as Wheatstone Bridge circuit. Now using this particular circuit, one can find the unknown resistance. Say, out of these four resistances, R1, R2, R3, R4, suppose we take R4, that is an unknown resistance. Now here, suppose battery supply total I current to the circuit. Now here we have to adjust the values of these resistances R1, R2 and R3 such that the current in this particular branch B to D, that is 0. It implies that galvanometer shows you 0 deflection. When galvanometer shows you 0 deflection, then we can say bridge is balanced. Or in other words, we can say when the bridge is balanced, always galvanometer shows you 0 deflection. So here we have to adjust the values of the resistances R1, R2 and R3 such that the galvanometer shows you 0 deflection. So current through galvanometer is 0 and we can say bridge is balanced. So here when the current I enter to this junction A, now suppose it is divided in two parts, I1 in branch AD and I2 in branch AB. Now B2D or D2A, D2B, there is no current. So this I2 from B, it will flow to C. Similarly, current I1 A to D, now that will flow from D to C. And when in C current I1, I2 enter, then resultant leaving, that is I1 plus I2, that is again equal to I. Now here suppose we consider the loop A, B, D, A. So A to B, we are moving in the direction of the current I2 through resistor R2. So the potential difference, that is minus I2 R2. Then B to D, B to D, in that particular branch there is no current. So potential difference is 0 in that branch. Now D to A, you are moving in the opposite direction of current I1 through resistor R1. So potential difference I1 R1 that is taken positive, that is equal to 0. So we can write I1 R1 equal to I2 R2. Therefore, I1 upon I2 that is R2 upon R1. Say this is equation number 1. Now consider second loop, that is B, C, D, B. So when you are moving B to C, you are moving in the direction of the current I2 through resistor R4, which is a known one. So the potential difference, that is minus I2 R4. Then C to D, you are moving in the opposite direction of the current I1 through resistor R3. So the potential difference, that is plus I1 R3. Then D to B, there is no current, so no potential difference. So when you reach at B, resultant is 0. So you can write I1 R3 equal to I2 R4. So you can write now I1 upon I2 that is equal to R4 upon R3. Clear to all of you up to this? Now compare equation number 1 and 2. So we can write R2 by R1 that is equal to R4 by R3. So here we can say when this happens, the bridge is balanced, because when we considered there is no current through the galvanometer, we derived this identity. So we can say this one is the condition to balance the bridge. If this condition is satisfied, definitely the bridge will be balanced and there will be no current through the galvanometer. Now here make R4 as a subject of equation. So R4 that is equal to R3 into R2 upon R1. Now R1, R2, R3, all these three resistances are known resistances and R4 was unknown. So using Wheatstone Bridge circuit, one can find the unknown resistance. Clear to all of you?